Hello geometry students, this is Mr. Figuet back with you for another math video, and today we are going to hop into our calculators and learn how to begin the process of solving trig equations. So prior to watching this video, please make sure that you have taken an opportunity to go through this intro, whether we did it in class together or whether you tried it as a warm-up on your own. The main objective of this warm-up is to make sure that whatever calculator you plan on using, I will be demoing with the TI-84 in this lesson, that you know how to go to the mode button, you know how to switch between radians and degrees, because we're going to be flipping back and forth in this a lot. And also, and I'm going to make sure I fix that in function mode, so your settings should look just like mine here, and then we have to be ready to switch back and forth between these two modes. And that you know that when given an angle, you can type that in sine, cosine, tangent, and yes, even the reciprocals, and make sure that you can find the appropriate ratios written as a decimal. So if you have that under control, let's go ahead and let's move forward. So a quick rewind back to earlier in this semester in Unit 5. We learned about the concept of finding and solving a trig equation. And the idea here is that if we know what the ratio is, and we want to know what the angle is, what we're going to do is use the inverse trig function. So if we had an equation like this, we know the ratio is 6/13. What I would do is go into my calculator and I would type in second sine and I would type in 6/13. So let's actually do that on the calculator real quick. So let's put ourselves in degree mode for this part. And what I'm going to do right now is go second sine, and we're going to put in the fraction 6/13. By doing that, the calculator is going to spit back to us an angle in degrees, which is 27.486. So what we exactly see here, round to the nearest tenth, that's 27.5. Now, back in our geometry unit, we were only talking about right triangle trigonometry. That meaning angles that lie between 0 and 90 specifically. And our calculators do a really good job at finding that value for us. But now when we look at trigonometry through a wider lens, now that we know about trig on the coordinate plane and that trig ratios can be any angle we want them to be, meaning they don't have to be restricted to 0 and 90, we actually know that because this ratio is positive, that this answer, that theta, is in quadrant 1 or in quadrant 2. And the reason, remember, it's in quadrant 2 goes back to our conversation about ASTC and knowing that the sine ratio is positive in quadrant 2. So really what this number represents in our wider lens is this actually represents our reference. Whoops, if I can spell it right. Our reference angle. And so back in right triangle trigonometry, the reference angle was always the angle that we were looking for. So there was no issue there. But this theta really represents our reference angle. And so when we think about quadrant 2, that we can actually find the quadrant 2 answer simply by doing 180 minus my reference angle. And so we actually get two different answers. 27.5 is an answer, but so is 152.5. And just to confirm, if we were to take a sine of 27.5 in our calculator, we would get that 0.4617. That is 6/13 as a decimal. And then if I typed in sine of 152.5 in my calculator and press enter, we would also get the exact same ratio. And again, just in case you don't believe me, here's 6/13. Okay, same thing. I mean, there's rounding a little differently because we're doing some rounding here, but ultimately it is the same. So with that being said, we need to now add in our thoughts about the quadrants when solving these problems. So let's go ahead and look at examples 1 and 2. We're going to do that in this video, and then there'll be another video after you've practiced these where we go into a little bit more advanced equation solving. So I want you to read this tip at the very top of the page. Really, really important. This is my personal hack in how I would use my calculator. So whenever you are solving using the calculator, what I recommend to do is to drop the negative sign when evaluating the inverse trig expression. The reason why is that will always result in you finding the reference angle. If you don't drop the negative sign, what that's going to do is give you one of the two correct answers. It always will. But you're not going to be sure of what quadrant it's going to be in. Sometimes it's going to give you a quadrant 1 answer. Sometimes it's going to give you a quadrant 2 answer. And even sometimes it gives you a quadrant 4 answer written as a negative angle. So you can do it that way, and you absolutely still could get the correct answers. But my recommendation is you always drop the negative sign when you put it in your calculator, and that's going to help you find the reference angle, thus being able to figure out both answers for theta. So in example 1, we are going to be in radian mode. And the reason I know that, let's write that in, we are going to be in radian mode because they specifically want me to get an answer between 0 and 2 pi. Now, one of the things that's going to be a little bit of a mind shift here is that the answers are not going to come out in that exact pi format, like 5 pi over 3 or pi over 2, because our calculators can only give us decimal approximations for the radians. So just remember little things like, for example, 3.14 is 180 degrees. 6.28 is 360. And so think about that original activity we did with the rubber band when we first learned what a radian was. We're going to be getting decimal answers for these. So without further ado, let's actually do some of these problems. So for question 1, I see that we have a negative value and its sign. So remember, if we use ASTC, we are going to get 2 answers for this. Since sign is negative, it's going to be quadrant 3 and quadrant 4. So I'm going to put little blanks down here just to represent that we're going to find 2 answers, and one's going to be in quadrant 3, one's in quadrant 4. Now, what I'm going to type into my calculator to find the reference angle is I'm going to type inverse sine, and you'll notice now I am not going to write the negative sign. I'm going to put 0.499 into my calculator. So let's go ahead and do that right now. So in my calculator, we first need to switch ourselves back over to radian mode, since this is going to be done in radians. And we're going to press second sine 0.499. And when we get our answer here, we're going to get 0.522. Let's go ahead and write these to 3 decimal places just to be a little bit more accurate here. So 0.522. Now remember that that is a radian value, okay? So what we're going to do to find our answer is that in quadrant 3, and I'm going to draw this, but I'll erase it. In quadrant 3, if we know our reference angle is 0.522, we know that to figure out the entire rotation, we would have to add pi to that. So in my calculator, let's bring that back up, we will essentially find my quadrant 3 answer by taking pi plus, and then you can actually copy the answer by pressing second answer, and that gives me 3.664. So for this final answer, let's round that to the nearest tenth. So that's going to be 3.7 radians, which is a little bit more than pi. So that's in quadrant 3. That kind of confirms things. And then in quadrant 4, a drawing in quadrant 4 would look like this. We want to find that entire rotation, and we know that this, our reference angle, is 0.522. And so once again, we're going to go back to our calculator. In this case, I'm going to do 2 pi, because that's 360, or the entire revolution, minus, and then I'm going to go up here and copy that answer down. And that gives me 5.76. So we'll say 5.8. So these are radian answers. So now it's your turn to try and figure this out. And actually, no, we're going to actually talk about this one because there is a reciprocal here that we need to address. So let's actually talk about that first. Because if you see, there is cotangent here. And the question might be, all right, well, there's no cotangent button on my calculator. How do I take inverse cotangent? So we're going to talk about that now. In this case, we have a negative value again. Let's talk about ASTC real briefly. If we want cotangent to be negative, that's going to be in quadrants 2 and quadrant 4. So my 2 answers here, I will have a quadrant 2 answer, which we'll write on that line, and a quadrant 4 answer, which we will write on that line. Now, rather than doing inverse cotangent, remember that we can write this as a tangent equation instead. I'm going to rewrite this as 1 over negative 1.66, because now I have the ability to find the reference angle of this situation by rewriting the equation. That means I can take inverse tangent. Remember, I'm going to drop the negative sign and put in the fraction 1 over 1.66. When I press enter in radian mode, it will give me the radian reference angle. So let's do that now. So let's go back over here. We're going to press second tangent. Let's actually clear that. Second tangent. I'm going to go ahead and insert my fraction. 1, notice there's no negative sign because I want reference angle, 1 over 1.66, and we get an answer of 0.542. I like to do 3 decimal places early on in problems here, 0.542. Okay, so now we need to find the quadrant 2 answer, and then we've already done the quadrant 4 process, so let me just visualize quadrant 2 for you briefly. We want to find that angle, and we know that the reference angle right here is 0.542. So to figure out the angle in quadrant 2, we are going to do pi minus, so let's go ahead and enter that in, pi minus the answer we just found. And so that gives me the quadrant 2 answer, and then as we saw earlier with quadrant 4, you're going to take 2 pi minus that reference angle. So let's go grab that. And now we have both our answers. So let's write those down. To the nearest tenth, I had 2.6 radians. That was my answer in quadrant 2. And lastly, 5.7 in quadrant number 4. So we're going to do 2 more examples here. We're going to use the same concept, but we're now going to move ourselves back into degree mode. So let's do those now. Okay. Now my challenge for you is degree mode might be a little bit easier for you to try. So my challenge to you is try to see if you can answer this on your own. Pause the video and then I'm going to go through the process. Okay, so in letter A, we are talking about a negative cosecant. So cosecant, remember, is the reciprocal of sine. And so sine is going to be negative in quadrants 3 and 4. So we're going to have 2 answers that we're going to get. And I'm actually going to go ahead and do this one while we're at it. So ASTC, cosine is positive in quadrants 1 and 4. So my answers will be quadrant 1 and then quadrant 4. I just like to put those answer lines down to help me remember what to do. Now, for the reciprocal, as I mentioned before, first thing I'm going to do is write that as a sine ratio. So I can rewrite this as sine theta equals 1 over negative 1.899. And then in my calculator to find the reference angle, what I'm going to type is sine inverse and then the fraction 1 over 1.899. That will give me my reference angle, and then we can go ahead and find my 2 answers. So let's switch over to degree mode. Degree mode, done. Okay, we're going to do second sine, insert my fraction. It's 1 over 1.899. Enter. All right, so we have 31.77. Now, for degrees, you can be a little less precise. I'm going to still write 2 decimal places. You could still write 3 if you want. So 31 point, we'll go say 77. Okay. Well, really, let's go 5. Let's just be safe. We'll put 775. Just to be consistent. So in quadrant 3, that's always going to be 180 plus the reference angle. So my quadrant 3 answer is 211.8 degrees. And then lastly, we're going to go do our quadrant 4 answer, which is going to be 360 minus, and then go up and grab that reference angle. So 328.2. So 328.2 degrees. Okay, so let's do that with cosine now. Nothing we have to change here. This is just going to find my reference angle simply by doing inverse cosine of 0.786. And when I throw that into my calculator, let's move this over that way so you can see it. Let's clear the screen just so it's easier to look at. Second cosine 0.786. And that gives me a reference angle of 31.187. So 38.187. Again, always write more decimals earlier on in a problem. Now, quadrant 1 is just going to be the reference angle. So that's actually just going to be 38.2 degrees. And then our quadrant 4 answer is going to be, as we saw earlier, 360 minus the reference angle. And that gives me 321.8. 321.8 degrees. And that is how we solve our first set of trig equations. So this is now your chance to go out and try some of these yourself. And then once you already have done these problems, I'll have some more algebraic concepts to walk you through in video 2. Guys, have an awesome day and good luck with your work.